Hello, hello, and welcome to the talk Back to the Future. We'll speak about couple very old academic ideas, which are just now coming back and hitting the industry. So, guys, we have couple topics to cover, but let's start our trip with programming. So, in the classical programming languages like Java, C Sharp, or C++, program is the sequence of statements, and these statements are invoked one by one. But this is not the only way how we could code. For example, in logic programming, we do not have a sequence of statements. We have the set of axioms and a set of rules. So in the logic programming, we try to model the application with logic. And axioms are the facts. Facts like Monday is before Tuesday. Or for example, facts like the week has 7 days. Yeah? So we have axioms which are facts. And we have logical rules. And a rule is a sentence like, when something is true, then for sure something else is also true. So, for example, if some number is dividable by 4, then for sure it's also dividable by 2. Or for example, the rule, if someone now is on data love, then for sure he's interested in data and engineering. And this concept of programming is not new. To be honest, it's pretty old. The first implementation of that kind of logic programming was in Prolog, and it was in the 1970s. And what is interesting is that still Prolog is developed. It's developed and maintained, and new features are added there, but mainly in the academic universities and departments. So Prolog did not reach industry. Yeah, there is not many companies using Prolog, but logic programming came into production, into business software with the language LogiQL. LogiQL was created and released a couple of years ago, and is extremely similar to Prolog or to Datalog, a different logic programming language. I call it Prolog on steroids. And for a couple of minutes, I will speak to you mainly about this logical programming language. But first, let's create a small example program to give you a taste how to create applications in logic programming. So let's assume that we want to create the app which will somehow model the relations in the family. So who is the father, who is the grandfather, who is the grandchild, and so on. So first, we have to have two things. We need to create axioms and logical rules. So let's start with the axioms. We could say that Mark is a man. Yeah, with plus, we are adding to the logical, we are adding the facts to our system. So it's like our data, yeah? With like our facts are like our data. With the minus, we could remove some facts, some axioms from the program. So we added Mark. Yeah, we defined the fact that Mark is a man. We could also define a fact that Joe is a man. And another fact that Mark is the father of Joe. And we could do as much as we want because it's like our data. Yeah? It looks like code, and it's a code, but it's a data. Facts are, to be honest, data. And now we need to define and create logical rules. So for example, we could define a rule that someone is a man or someone is a person. To create a rule, so if something is true, then something else is also true, we have this arrow. And here, the arrow is from left to right. So it means that we need to read it from left to right. So here is, if X is a man, then for sure X is a person. Yeah, pretty sure, and probably it's true. Yeah, probably it's true. Another rule, we could define what does it mean to be a father. And also the arrow is from left to right. So we read it from left to right. And it will be, we could read it as, if X is a father of Y, then for sure X is a person, and because in logical comma is like and Y is a person, and X is not equal to Y. Yeah, because only probably God could be his own father, so we need to define that X is not equal to Y. And we could also define what does it mean to be a grandfather. And here we have arrow from right to left, so we read it from right to left, and it will be like, if X is a father of T, and if T is a father of Y, and if Y is a person, then for sure X is the grandfather of Y. Yeah? So this definition is saying that father of my father is my grandfather. So guys, I hope it's clear. Probably many of you are familiar with Prolog or Datalog from university. But what is interesting is that this is now a whole program. We could of course extend it, but now we could do some invocation on that kind of predicate, that kind of logic which we defined a couple of seconds ago. For example, we could ask, dear LogiQL, give us all of the grandchildren of Mark. Yeah? So we have this X, and LogiQL will populate this X with all of the facts which are derived from this logic and from these axioms. I could do also something like this. We could ask LogiQL to give us all of the grandfathers. Yeah? On X into X, LogiQL will put all of the grandfathers, and we ignore the grandchilds with this wildcard, which is called the anonymous variable. We are only interested in the grandfathers. So something like this we could do in Datalog in Prolog, but LogiQL is much bigger language, because it has constructions which will let the programmer to create big applications inspired from different languages. So for example, I will explain to you LogiQL, the new ideas in LogiQL in, let's say, 5 minutes. So in LogiQL, we can easily create new entities. Yeah, some kind of the new things in our system. We do it with the arrow and the dot, and you can think about it as like classes, for example, in Scala or in Java. Yeah, class is some new entity. So in LogiQL, we could do it with construction like this. And when we have something like this, the new entity or new entities created by us, we could use it in the definition of the different predicates. So here we could create another predicate and use the entity which we created a second ago. Also, all of the predicates, all of the rules had the rounded bracket, yeah, on the previous slide and also here. But we could create a predicate with the square bracket, and that kind of predicate will be a functional predicate. So it will be like a function in mathematics. So for one argument, we have just one result. And thanks to this concept, we could model that item has just one description. Because description is a functional predicate. And also in LogiQL, we have a lot of built-in types, the typical built-in types like you know from different languages. So for example, we have strings, we have float, we have int, decimal, and so on. And we put that kind of definitions in the export section. And export is like public in Scala or public in in Java. So thanks to this, all of these predicates, if they are, and they are, in the export section, could be used somewhere else in a different part of the application, because they are, let's say, public, in the public scope. And the definition for rules, for axioms, we put in clause. So in clause section, we could do everything what we want with the predicates which are here and with the predicates which are imported, and about importing, I will tell you in a second. And we could create rules with arrow from left to right. This is called a constraint. Yeah, you are putting some kind of a constraint, but this is a rule. And from the rules with arrow from right to left to define some logical rules. We also has a alias all keyword. And thanks to this, we could import some different predicates from different parts of our application here and use it. Yeah. So it's like import in Java or in Scala, and it's a mirror of this export. Yeah. So when something is exported somewhere else, I could, with alias all, I could import it to my to this file and do something with the imported predicates. And all of our logic is encapsulated in blocks. Yeah? Our encapsulation is in blocks, and the logical programs are made with thousands or hundreds of blocks like this. And what is interesting in LogiQL, we could, during runtime, we could take some block out from the application, and during runtime, we could put some block inside. Yeah, so this is the basic of what is new in LogiQL, and there is much more. So, for example, guys, if you want to calculate in LogiQL the equation like this, yeah, some simple sum of two variables, let's call it the variables, in LogiQL is straightforward. Sorry guys for a second. So we create a predicate, a functional predicate T, and we have another built-in predicate in LogiQL, which is called AGG, for aggregation to simulate this guy. And we have cost multiplied by. So as you probably agree, the mathematics side and the Prolog and the LogiQL side is almost the same. It's extremely easy to understand this piece of logic. And we could do a bit more. For example, if we have equation with quantifiers, it's also easy to express in LogiQL. We could create two rules. The inner one, the sum of amount multiplied by, we could put it in one new predicate. Let's call it total nutrients, and it has the similar definition, yeah, amount like by. So this piece of code, this line is almost like this line of mathematics. And to express the quantification and this rule is extremely easy to in LogiQL, because we could create a constraint. Yeah? We could create a constraint, and with these two rules, we could express and define this mathematical equation. And what is more interesting, in LogiQL, we could also do something different. We have built-in line programming algorithm and some pragmas. We will see the pragmas in a couple of seconds. And we could have the system where predicate by, yeah, this guy, by, so this guy, by, and this by, is empty. So we do not have any facts. We do not have any axioms there. So nowhere in our code we have plus, yeah, plus with some value, plus with some different value. We have it nowhere. But maybe we want LogiQL to figure out what kind of values we need to put into the by predicate automatically according to some conditions. So we could, for example, think that we want LogiQL to populate by predicate in that kind of way that this formula is minimized. Yeah. So let's say in machine learning terms, this is our objective function T. Yeah. So this guy T, This is our objective function, and we want to minimize it. And our only variable is the by. So in LogiQL is straightforward because we have a syntax in the language, which is called the pragma variable and pragma minimal. And you could say by is our variable, so this is our predicate, is probably empty. Please LogiQL populate it with some data, and please minimize the t, so minimize this guy. And of course, this is not all, but if you are interested more in LogiQL and also in general, what is how to program in logical languages, I recommend you the book written by Terry Halpin. It's really good. It was released a couple years ago, and probably guys, soon in the future we'll see more logical languages in production in the industry, because for example, it was 4 days ago, am I right? April 12th, Google announced that they created a language Logica, which is also implementation of logical programming. This is open source, and it's extremely similar to Datalog, to Prolog, and to LogiQL, and it was released 4 days ago. So if you are interested, check it out, and probably, maybe it's a guess from my side, in the future we'll see more of this old idea coming back of logical programming, like Google is now releasing the logical language. For a second, guys, let's forget about LogiQL. We'll speak about something different, but then we'll go back to logic programming. Let's speak a bit about LogicBlox. So probably some of you heard about LogicBlox platform. So in the summary, LogicBlox is a framework to create big data applications. It was introduced to the world on the conference called SIGMOD on 2015. It was 7 years ago. Yes, 7 years ago on the SIGMOD conference. And if you are interested in all of the novel features which are in the system, I recommend you to read this paper. It's really good. It's one by one explaining what is new, what new idea is in LogicBlox. So, for example, live programming. Yeah, live programming is a nice feature in LogicBlox, which is explained there. But what is interesting for our talk, so for today, is just one feature, one core idea, which is the architecture model of how to create big data applications. So nowadays, the standard architecture of creating applications is a 3-tier model. Yeah? We have the presentation layer, we have the business logic layer, and we have the database. So presentation layer is the front end, written in JavaScript, TypeScript, or Angular. Business logic layer is written in Java, C# or Scala or C++, and we have the database. Yeah? The last layer is the database, and between the business logic layer and the database, we have data access layer. But the LogicBlox creators had a different idea. They, in the paper and in the platform, they had idea to squeeze these 2 layers, to squeeze the business logic layer and the database into one layer. And guys, now what do you think? Because I'm quite sure that now you think that this is not the new idea. Yeah, something like 1 million years ago, people were writing directly in the SQL databases with some stored procedures. But with big data and with LogicBlox, it's a good idea. I'll just give you a second to think why. It could be a good idea because when we work with big data applications, it means that we have a lot of data. Yeah, we have a massive amount of data, and with the old architecture, when we have the business logic layer and the database, our application probably will spend a lot of time on putting something on the database and retrieving something from the database, because we have a lot of data. Yeah, and that kind of thing is not good, and it doesn't give us anything. Yeah, because we are when we have the application, we want our application to spend time on calculation, on calculating some logic, not on retrieving something from the database or putting something to the database. So in LogicBlox, and probably you will now guess it, these two layers, business logic layer and the database, are squeezed into one layer under one language. And this language is, of course, logical. So the backend developers are writing code only in logical, and they don't need to think about the database. They don't need to think about data access layer, because they only have logic. Yeah? These axioms, these facts, these are data, but in logical, data is like code and code is a data. There is no, let's say, distinction between these two things, because there is just one language called logical. And there's also one reason why logical and LogicBlox could be a good idea for, and it's a good idea for big data, and it's because of parallel computation. So let's guys assume that we want to calculate the predicate like this, which is made of conjunction of three different predicates. Yeah, we have and, we have commas here. So in logical, it's extremely easy to have parallel computation. It is for free. Not like in different languages, but when the programmers need to create their own constructions to get and to have the parallel computation with threads, for example, or some different mechanism. In logical, straight away, this predicate could be calculated on one core or one processor of our machine. This predicate could be separately during the same time calculated on the different core of our machine, and this guy could be done automatically on some different core. And also we have some tricks here called incremental maintenance to do that kind of calculations extremely fast. But the idea is programmers think only about logic, not about data, not about running something in parallel. Only logic matters. And also LogicBlox came with a quite big standard library of predicates, of facts. So for example, if you want to create CRUD, a simple create, read, update, delete application as a web service somewhere in the internet. So in the standard library, there are already a lot of predicates to serve and to handle HTTP requests like get, pod, post with the code which will look like this. So this is LogicBlox. And now, guys, let's forget about the LogicBlox for a second. We'll go back to LogicBlox and logical in couple minutes. And now let's go into some old different idea, which is called automated software engineering. So automated software engineering is a subdomain of computer science, where researchers or developers want to create tools which will help different developers to write programs. Yeah, which will ease the development of programs, or even to totally replace the programmer with some neural networks, and that programmers won't be needed because neural network will code for you and generate code for you. About neural networks we won't speak today, but I want to speak about something very, very old, which is the concept of application generators. Yeah, probably you heard about application generators and code generators. So the general idea is that sometimes we know that we would like to create not just one application, but couple applications, which are pretty similar. For example, we know that we want to create application to do prediction for some grocery industry, which will predict how many apples or how many bananas we need in which shop, in which period of time. But we know, or probably, in the near future, we would like to create a similar application, but doing the predictions for the clothing industry, which will predict which pair of jeans or which brand of shoes will be more popular in which shop, in which period of time. So we could create that kind of applications manually, twice. Create first application, then create and then code the second application. But of course, these applications are a bit different, but the core is the same. The mathematics, the predictions algorithms are probably the same. So with the concept of code generators, we are not creating separately two applications or three applications. We will create the application which will generate different application. So based on some inputs, some magic will happen and generator will create one application, for example, for grocery industry. And with different inputs, the code generator will create another application, for example, for clothing industry or for something else. To give you some kind of the bigger taste, I like the metaphor of the Lego bricks. The metaphor of the Lego bricks, because usually that kind of application generator is a program. This is a program which is generating programs. So usually application generator is a program which could be thought and understand as the Lego bricks, but each brick represents some functionality. So for example, we have bricks for artificial intelligence, we have bricks for graphical user interface, bricks for machine learning, and so on and so on. And on this input, user somehow specifies which blocks I want to choose in my application. And application generator, when he will take the inputs, will glue these Lego bricks together, for example, like this, and will create one application, or will create and glue these bricks in different way and create another application and another and another and another, because code generator could create an applications. So guys, we some time ago we created that kind of, let's say, new application generator for retail industry. First, I will tell you why, and then how. So guys, have a look on this slide. So LogiQL, this is a great language for writing applications. It's a great language for us for what we do, but it's not a great language if you want to have a generic programming. If you want to express something in a generic way. To show you this, let's check code which is here on the left side. This is a real piece of code from one client, from one application, which is doing feature engineering. And on the right, I have a different piece of code from a different application to a different client, which is also doing feature engineering. And probably now you see something. It's for sure, because it's you have a title called duplication. So the problem is, but on the left side and on the right side, and these are two different files from two different applications. So on the left side and on the right side, we have similar code, extremely similar code. So because we have a feature here, we have the feature here, feature key here, feature key here, and also this rule, here is category feature, here is subclass feature, but syntax is similar, Syntax here and syntax here is similar. Also, this guy is similar to this guy. So we had a problem. We have code duplication, and in this way we are breaking the sainted principle of software engineering, which is dry. Don't repeat yourself. So if you create some piece of code, don't copy it and copy paste it somewhere else. Just reference it. But this is easily possible. This is easily possible in some higher language, not higher languages, but in languages like Java or Scala or C#, where we have some higher concepts. For example, we have classes, subclasses, monads, traits, and so on. But in LogiQL is extremely simple language, and we have just one abstraction, which is a predicate. Yeah? We don't have classes. We have predicates only. We don't have monads or traits, only the predicates. So to give you a better understanding why that kind of code duplication will happen, let's check a very simple rule, ABS fun. So this rule is calculating the absolute value of some different functional predicate. So for example, if fun predicate will give us x and it's -5, ABS fun will give us 5. If it gives us -6, we'll have 6. Yeah? Absolute value. And we have that snippet of code is extremely easy to understand and quite short. But as you see, we have only 3 dimensions here. Yeah, everything as an OLAP cube, we have only 3 dimensions. We have item, store, and day. But the problem is that maybe we would like to write soon the application for the clothing industry and use the same snippet of code. And it's problematic because almost for sure, clothing industry also cares to handle in the OLAP cube, handle dimensions of color of some jeans or of some shoes, or style of jeans, shoes, or different clothing. And now it's a big problem for us because we cannot reuse this guy. Yeah? We cannot reuse this snippet of code. We need to do some minor mini changes in this snippet. So we need to change the body. Yeah, we need to change the body. And changing the body is not so problematic, but still is not nice. Yeah, we are doing adding some small changes here. The bigger problem is that we needed to change a signature. Yeah, we needed to change a signature and add here color and style. And this is a big problem because if we have application with thousands or tens thousands of rules, and many of them are using this predicate, so now everywhere in the code, we need to do some kind of the small mini changes and add this color and style. Yeah, so this is, I hope you have a taste that the only abstraction is a predicate, and LogiQL is not a good language. Yeah? In general, logic programming languages are not a good language to make something generic, like in Java or, for example, C++ with classes, with some class hierarchies. But we could solve it. We could solve this problem. Yeah, we could think about creating some higher abstraction, and we could do it in many ways. But one of the way is that now we know about code generators. So instead of manually writing the rule for ABS fun or something else, we could create the function, which is called ABS fun, which is taking some function, and based on this function, is generating us the rule. Yeah, so just create a code generator, which will generate a LogiQL code. So we don't need to write it manually. And that kind of thing, this is the DSL. Yeah, in some part, this is a domain-specific language for the LogiQL. We could do it in any language, in the programming language you want. We like to do it in Scala because Scala is great for creating DSLs with thanks to the mechanism like, for example, implicits or type level programming thanks to shapelets. So we did it in Scala. And if you see on the right side, we have the LogiQL snippet. This is like a, let's say, generically written ABS fun in LogiQL, ABS fun rule. And on the left, it's the equivalent in Scala. So we have ABS fun, which takes some fun, so some different predicates, any predicate, yeah, because this is Scala, and we have here a make rule. Yeah? A make rule. So as you probably read this piece of code and see this piece of code, you see some similarities. Yeah. So to create the rule, something with the arrow, we have the make rule, and everything what is before the arrow. So here is only this guy. We have created a constructions and a DSL to call it a head, and everything after the arrow, before the arrow, the body, the body of the rule we have in the body here, and we have the comma, and for the comma we have the word end. Okay, so we are able to create DSL, a generator which will generate that kind of function. And if we are able to generate that kind of function, we are able to generate that kind of rule. We are able to generate every different rule. Yeah? And this is what we did. We created for all of the rules which are extremely common in our application. We created that kind of generators in Scala. Yeah, that kind of generators in Scala. But what is more interesting is that this language, this DSL, is our internal language. Only Scala programmers, LogiQL Scala developers are writing code like this. But the developers which are creating applications, the data engineers and data scientists, they have a higher abstraction because we created that kind of generators for generating all of the common rules, and we also encapsulated that kind of generators in generating whole functionalities. So the language, the second DSL, the higher language, which is our API, to be used by developers and the data scientists, is like this. It's almost English, yeah. It's almost English, where data engineers or application developers which wants to create a concrete application for some specific client in LogicBlox, they have that kind of language with JSON-like. It's called Hokon. Yeah? We use Hokon to express our functionalities. But all of these guys is like a Lego brick. So the programmer has the Lego brick for scaling, another Lego brick for predefined features, for Fourier series, accuracy metrics, and around 100 of that kind of functionalities. And of course, they are configurable. Yeah, you could have calculation of the trend with some scaling method, different ways how to calculate the predefined features. And what is interesting is that each of these bricks, this brick, and this brick, when it's defined, it will generate a couple thousand or a couple hundreds or couple thousand lines of code. So now our developers don't need to code so much in LogiQL, because that kind of thing will generate a LogiQL for them. Yeah, and this is especially great for data scientists or data engineers, because they want to speak with mathematics. They don't want to program, write code. They want to express some algorithms with mathematics. So they just need to learn this very simple language. About how to create this DSL and this external higher DSL and this DSL from the previous slide, this guy, I recommend you to check my LinkedIn. I have a couple of the videos, a couple of the lectures, which are mainly speaking about some theory of, let's say, compilators, or theory of programming languages, how to create a DSL, two DSLs like this. But now our code generator. So now we programmers don't need to write everything in LogiQL like it was before, everything in LogiQL. They could now we have 3 inputs and the code generator, which is generating applications. So we still have, and probably will have forever, some static pool of LogiQL rules and axioms written once. So for example, here there is the logic for calendar. Yeah, there is a big repo of a couple thousands of rules which are true. For example, for retail industry. So about calendar, yeah, that the Monday is before Tuesday. This is written once, and it's always true. We don't need to generate it because it's written in real LogiQL. This is one input. Second input is client-specific libraries, yeah, because of course each application is unique. Yeah, on on some parts are unique. So these unique parts we are writing in logical, still in logical. But sometimes when we see that some unique parts of one application and unique part of the different application is the same, we are trying to abstract it and put it in the code generator. So this part is small. This is only something what is unique, and also unique for the code generator. And the most important input, this is the way how our programmers are coding. Yeah, how our programmers are coding is this guy, this data model. And this data model, this is the program in this higher language which you saw on the previous slide. So almost like English, like some small language, developers could express what kind of Lego bricks they want to have in the generated application. And based on these three inputs, on static code, client, manually written, specific libraries, and this data model, code generator is generating us the app. So instead of writing application for 2 months, we could generate it, for example, in a couple of weeks, or even shorter. If we'll have time on the QA session, I would like to, if you are interested, of course, I would like to show you this application generator in action, how it's searching the workspace of all of the predicates and generating some code which is able to be compiled. So guys, this project, Model Refinery, this generator, yeah, this guy, Model Refinery, is not released, is not available on the internet yet, probably will be in some form available soon. But the LogicBlox and Logical are available on developers.logicblox.com, and you will find there always the newest release, the past releases. We are putting new software, I think twice per month, or even a bit more often. Documentation, publications, and the sandbox. So if you don't want to install LogicBlox on your local machine, you have a sandbox when you could have fun with Logical and write some rules and check if it's working or not. So guys, I hope that you liked the talk, and thank you